Welcome to this short and interesting topic, polygons. So the first part is going to concentrate on interior angles of a regular polygon. The second part, exterior angles of a regular polygon. So both the interior angles of a polygon and the exterior angles of a polygon are going to be delivered in this video. So what is a polygon? A polygon is just a plane shape enclosed by 3 or more lines. So it's just a shape that has 3 or more lines. There are two types of polygons. There is what is called a regular polygon that has all sides and angles equal. Then there is what is called an irregular polygon, which doesn't have all sides and angles equal. So this topic is going to concentrate on formulas that have to do with regular polygons. For irregular polygons, we don't usually have formulas, so we can just use basic understanding of angles and lines to solve problems that have to do with irregular polygons. So this is an example of a polygon, a triangle. And this triangle is a regular polygon. Well, this one is an irregular polygon. So as you can see, for a triangle, this side and this side and this side seem to be equal, though not exact, but they seem to be equal. But this one, you can see this side and this side, they are not equal. So this one is definitely an irregular polygon. So there is a way to name polygons. So polygons are named by the number of sides they have or the number of angles they have. So we have these numbers here, which proportionates to the number of sides or the number of sides or the number of angles. So basically, these this is 3, but the Greek word for 3 is tri or tri. So a shape with 3 angles is called a triangle. Triangle, meaning 3 angles. So that's where the name triangle comes from. Then when it has 4 corners, it's quadrilateral. Quadrilateral. Quadri means 4. So this is where rectangles and if it's a regular polygon, of course it's a square. So a square and rectangles are quadrilateral. Then if it has 5 angles or 5 sides, we use the word pent. So penta means 5. So pentagon, it means it has 5 sides or angles. Then 6 is hexa. So 6 sides, hexagon. 7 it's heptagon. 8 it's octagon. 9 is nonagon, and 10 is decagon. If you look closely, these are octagon, nonagon, and decagon for the last 3 months of the year: October, November, December. October, November, December. Though October is not the 8th month but the 10th month. So in the old days, there was a calendar where October was the 8th month, then November was the 9th month, then Decagon, December was the 10th month before some July and August were added. So it's just a reminder. Okay, so oct is 8, non is 9, dec is 10. Even though October is 10th month, non is 11th, and dec is 12 because of the 2 months that were added to the old calendar. So sometimes in the question they can say find something about the heptagon. The word hept should remind you that this shape they are talking about has 7 sides. So it's important to master these. So we're going to first take a look at what is called sum of interior angles of a regular polygon. Sum of interior angles of a regular polygon. An interior angle of a polygon is an angle inside the polygon between 2 adjacent sides. 2 adjacent sides mean 2 sides which are connected. The angle in between them inside the polygon is called an interior angle. So the sum of all interior angles of a regular polygon is given by this formula. Sum is equal to n minus 2 times 180, where n is the number of sides of that polygon. So if you have this polygon, then the interior angle is this. This is the interior angle. This and this and this. These are the interior angles. So when what it means, it means when you add this and this and this should give you 180. Sorry, not it should give you 180. When you add this and this and this should give you the number you're going to get here. We know that the sum of interior angles of, in short, we have that tendency of saying angles in a triangle add up to 180. So how true is that? The n for a triangle is 3 because there are 3 sides. So if you put 3 here, you're going to have 3 minus 2, which is going to give you 1. 1 times 180 gives you 180. That's why we say angles in a triangle add up to 180. Mean that when you get this interior angle and this, you add them up, they will give you 180. Okay, but the main point to get from this is when you add the 3, they should give you what you're going to get here. Then given the sum of all the angles, let's say you have the sum, then the size of each of the interior angle of a regular polygon of side n is given by this formula. So if you want to know the size of each of the angles in a regular polygon, the formula is interior angle is equal to sum of the angles, which of course you have to get using that other formula, divided by n, where n is the number of sides or number of angles. So by side I mean the side of this one angle. And for a regular polygon, like I said, a regular polygon has same sides and same angles. So the value for here is the same value for here, and it is the same value for here. So there is an example here. The figure below shows a regular polygon. Find the sum of the interior angles, b the value of x. So they want us to know the sum of all the interior angles, then b the value of x. You can see that x is an interior angle here. So they're just asking us to find the interior angle of this regular polygon, which is a pentagon because it has 5 sides. So this is a solution. Don't go ahead, just follow me. So first you write the formula for the sum is n minus 2 times 180, and n, of course, that has the shape have been given as 5 sides. So here where there's n, you put 5. So when you put 5, it's going to be like this. So 5 minus 2 to give you 3. 3 times 180 is 540. So the sum of the angles in that pentagon is 540 degrees. Now the value of x, they are talking about the value of the interior angle. So interior angle is equal to sum of angles divided by n. Sum of angles, which is 540 divided by n. How many sides? 5. 540 divided by 5, it will give you 108 degrees. So x is 108 degrees. Next, we look at what is called sum of exterior angles of a regular polygon. What is an exterior angle? An exterior angle of a polygon is an angle between a side and an adjacent side extended outwards. Don't worry about the English here. I will show a diagram for you to understand. So the sum of all exterior angles of a regular polygon is 360 degrees. So for exterior angles, there's no need to find the sum. The sum is fixed. It's always 360 degrees. So there's no formula like the interior angles. So given a triangle like this, given a polygon, like this, then let's say one of the sides is extended, then the exterior angle we're talking about is this. So the exterior angle, you get it by, of course, extending one of the sides, then finding the angle between the extended part and the adjacent side. So for example, if you want to find the exterior angle here, then maybe one of these should be extended, then the angle between the extension and the adjacent side, that's the exterior angle. So the sum of all the exterior angles should give you 360 degrees always. The size of an exterior angle of a regular polygon is given by the formula. So exterior angle is equal to 360 degrees divided by n, where n is the number of sides or number of angles. So for such a triangle, the value here is, you just calculate how many sides, 3. So 360 divided by 3, it's 120. So this is 120 degrees. So there's a question here. The figure below shows a regular polygon. Find the value of x. They want us to find this exterior angle. So we just get 360 divided by n. How many sides? 5. 360 divided by 5, 72 degrees. Now let's take a look at a more complicated question that needs a bit of thinking. So given that ABCD is a regular pentagon, so we have a pentagon here. Find the value of angle ACD. So we have a pentagon here. The regular pentagon means that all sides are equal and all angles are equal. So they want us to find the value of ACD. They have drawn a line here to bring complications. So they want us to find this angle here. So what are we going to do? What we're going to do is we're going to find the size of this angle. Okay, so once we find the size of this angle, then we're going to use another fact about triangles. So if you look this side, there's a triangle. So the truth about this triangle is they have shown these two markers here, which shows that this side and this side are equal. So if this side and this side are equal, it means also that this angle and this angle are equal, which means it is an isosceles triangle. For those who know types of triangles, an isosceles triangle has two sides equal and also two angles equal. So if these two angles are equal, then we're going to use this fact to find the value of this angle. Once we have the value of this angle, we're going to say that interior angle of we had calculated minus the angle here, then we'll have the angle here. To understand exactly what I'm trying to say, let's put what I've said into practice. So first, we're looking for angle ACD, which is angle angle BCD minus angle BCA. So value of angle BCD. So this BCD is the interior angle I was talking about. So first we have to find sum of angles divided by n. So sum of angles is given by the formula n minus 2 times 180, where n in this case is 5 since it's a pentagon. When you put 5 there, we're going to have 5 minus 2 times 180. It's going to give us 540 like we calculated earlier. So this value of the interior angle is this 540 divided by n, where n is the number of sides, which again is 5. 540 divided by 5, it gives us 108 degrees. So we know the value of BCD. So in short, BCD we have calculated it's 108 from here to here, because all the interior angles, all these are 108. So if this is 108, it also means this is also 108, right? So we want to find the value here, so that from 108 we remove this, then we'll remain with what we want. So this 108 and these two, which are equal, when we add them, should give us 180. Angles in the triangle should give us 180. So we're going to say value of angle BCA. So angle ABC, which is 108, plus BCA plus CAB. Sorry, plus BCA plus BAC. So we're talking about this plus this plus this. When we add them, they should give us 180. But we know that this and this are the same, so we can just say ABC plus this ABC, which we know is 108, plus 2 times, since these are the same, BC and BAC are the same, so we can just say that it's 2 times BAC. You can use 1 BAC in this case, this BAC. So it's like we have said this is x and this is x, so x plus x is 2x. Okay, so 2 times x, which is one of these. So angle ABC plus 2 times angle BAC is equal to 180. So angle ABC is 108. So we can take 108 the other side to give us 72. We can divide both sides by 2, which gives us 36. So angle BAC is 36, but BAC is the same as ACB. So we continue to the last part. So what we do is we say angle ACD, which is ACD, we get it, of course, BCD minus BCA. So BCD is 108 and BCA will calculate it to be 36. Remember, BCA, this angle here is the same as the angle here. So 108 minus 36, which gives us 72 degrees as angle ACD. So this marks the end of this topic. Hope you have enjoyed this short topic. Otherwise, happy solving.